Hi, this is Mr. Che. Glad to see you back for week 3. I know it was a little tough getting through that first portion, but I'm glad you're here. And so let's get started. I'm going to share my screen. I'm going to show you some slides, and we'll start from here. Okay. So last week we went over adding, subtracting, multiplying, and dividing different functions. Okay. Today we're going to go over, and I kind of previewed this last time, but today I'm going to go over composite functions. Okay, so what you see here is, first of all, the composite functions are functions within a function, pretty much. Okay, and so if you ever see the f of g of x, okay, this and this are the same thing. Okay, so what you're going to do is you're going to start the inside first. So you're going to start with the function on the right. Okay, and then whatever you get from that, you're going to plug that into the f function, or whatever function's outside. Okay, in this case, it happens to be the f function. Okay, so let's give you an example here. All right, I have the f function of x cubed, and I have the g function of x plus 2. And I want to find the f of g of x, okay, which again, these are the same thing. Okay, you're going to get the same result. So what this example shows is that what they did was they plugged in the x plus 2 in for the g of x, because the g of x is equal to x plus 2. And what they do afterwards, they plug this x plus 2 in for the f function, which is the x cubed. Okay, and so it ends up becoming x plus 2 to the third power. Now when you do this, a lot of people make the mistake that ends up where people just put x cubed plus 2 cubed. But remember to FOIL it all out. You have to multiply x plus 2 times x plus 2, FOIL that out, and then multiply that answer to the x plus 2, and that's where it becomes x cubed plus 6x squared plus 8x plus 8. Okay? Let's go for the next one here. Okay, so these examples are a little difficult because they're using squares and square roots, but just hang in there with me. Okay, so if here is the h function of the square root of 2x minus 4, here's the k function of x squared plus 2, and what they're looking for is the k of h of x. Okay, so what you're going to do is you're going to plug in, or they want the h of x first. Remember, you're working inside first. And so you're going to plug in the square root of 2x minus 4 inside the parentheses. Then what you're going to do is you're going to evaluate the square root of 2x minus 4, and you're going to plug it into the k function. And so that's why it's the square root of 2x minus 4 squared plus 2. Okay, I hope that makes sense. So what they did was, again, they plugged in the h function, the square root of 2x minus 4, and they replaced it with this x. Okay, that's what this means. So once you do that, you square it, which ends up becoming, once you square a square root, you get rid of the square root. So it becomes 2x minus 4, and then here's the plus 2's from here. Okay, you combine like terms, and the final answer is 2x minus 2. All right, so let's do one on our own. I'm going to share my whiteboard with you. Okay, so I have, let's say I have the g of n is equal to 2n plus 3, and I have the h of n is equal to n minus 1. And what I'm going to do is I'm going to get the g of h of n. Okay, so I'm going to start off with this here, right? And this ends up equaling what? The g of h of n. So so here's the h of n. I'm going to substitute the n minus 1 in for this function here. So it'll be the g of n minus 1. So what we're going to do now is we're going to substitute the n minus 1 in for the variable here. Okay, so it ends up becoming, because this is the g function, so it ends up becoming 2 and then n minus 1 plus 3. You distribute this, it becomes 2n minus 2 plus 3, and this ends up becoming 2n plus 1. And that is your final answer. Okay? All right, any questions on that? Let me know. Okay, what if, now I'm going to erase this a little bit. What if they put a number inside? Let's say they put the number 2 inside. Okay, well, you're going to do the same thing. You're going to use this number inside and you're going to replace that with a variable. So you're going to start with the h function first, because remember, you start from the inside, so it ends up becoming the g of h of 2, right? So the h of 2, what you have to do is you have to evaluate h of 2, that equals 2 minus 1. I remember I'm replacing the 2 with the n here, okay, because that number inside the parentheses means that you have to replace that number with the variable, okay? So 2 minus 1 equals 1. So then I have to get the g of 1, and so I have to get the g of 1. And so I'm going to plug the 1 into this function, so it ends up becoming 2 times 1 plus 3. So 2 times 1 is 2 plus 3. So the final answer to this, so the g of h of 2 is equal to 5. Okay? All right, any questions on that, let me know. All right, we're going to now, my computer, we're going to now deal with inverses. Okay, give me a second while I pop up this. I should have had it popped up, but I'm gonna. So now we're dealing with inverse functions. Okay, so you're gonna try to find the inverse of certain functions here. Okay, and I hope that you saw the video before on like one-to-one functions and seeing if it's inverses one-to-one. Remember the horizontal line test. I hope that you saw that, looked at that video. That will be important later on, okay? But for the sake of this assignment, what we're gonna do is just focus on how to get the inverse of different functions, okay? So for your homework, you were given in the beginning, I'm gonna give you examples. So you're given like points, like 2, 3, 5, -8, 10, 2. I'm just giving you, I'm just making up those numbers. And they ask you to get the inverse of these points. Well, for this, all you have to do is just switch the x and the y. Okay? All right. And remember how important the inverse is, okay? The inverse helps us solve different problems. It helps us invert things so that we can kind of get to the variable. You're working backwards, in other words, right? So when you get to an equation, let's say I'm going to do number 6 because I believe you have to do the odd numbers. So I'm going to give you number 6 as an example. Let's say number 6 is y is equal to -8x plus 16. Well, similar to what we did with the x and the y's, we're going to switch the x and the y here as well. So it's going to be x is equal to -8 times y plus 16. Okay? Then from there, what you're going to do is you're going to get the y by itself because you want to get it into slope-intercept form. Okay, and then this will be the inverted line of the original of this right here. So you subtract the 16 first. It will be x minus 16 is equal to -8y, and then you divide by -8. And so y is equal to -1/8x. Remember, there's a 1 in front of this x, plus 2. Okay? All right? And so this is the inverse of this. Okay? All right? I hope that makes sense. All right? Next is, let's do like number 12, okay, on your homework. So number 12 is y is equal to x squared minus 4. Okay? What you're going to do is you're going to switch the x and the y, and then you're going to solve for y. So then you add the 4 to both sides. It will be x plus 4 is equal to y squared. And then you get the root of both sides. And the reason why you want to do that is because in order for you to get y by itself, you have to get rid of the square. Now, how do you get rid of the square? You get the square root. Okay? So it ends up becoming y is equal to the square root of x plus 4. Okay? So this is the inverse of this right here. Okay? Let me do one more problem, actually 2 more problems for you. Let's do a problem like 16. So 16 is y is equal to the square root of x plus 5. And it says y is greater or equal to 0. Now, for this exercise, you can kind of ignore this. And the reason why it's there is because no matter what you get from a square root, okay, you can't get a negative number. And that's why this disclaimer is there. Okay? But for all intents and purposes for this problem and for us trying to find the inverse, you don't really need this right now. So for this problem, let's look at this equation. You're going to switch the x and the y. And then again, you want to get rid of the square root. Okay, so remember the last problem, you want to get rid of the square, so you got the square root. This time you have a square root and you want to get rid of the square root, you have to square both sides. Once you do that, it becomes x squared is equal to y plus 5, right? Because the square gets rid of the square root. And then you subtract the 5 to both sides. So y ends up equaling x squared minus 5. And this is your inverse of that equation. Okay, so I hope that kind of helps with these problems. Let's go to the bottom half of this worksheet, and it's 19 through 23. What you want to do is you want to get, I'm going to do number 20. You want to get the f of g of x, and you want to get the g of f of x. And if you do these two, if you evaluate both composite functions and they both equal x, they are inverses of one another. Okay, so for number 20, we have the f of x equals 5x plus 2, and we have the g of x is equal to x minus 2 over 5. Okay, so let's evaluate both of these here. So this goes inside here, so it ends up becoming f and then x minus 2 over 5. Right? And then let's evaluate this. So let's plug in the x minus 2 over 5 in for this variable here because this is the f function. So it ends up becoming 5 times x minus 2 over 5 plus 2. Okay? You cancel these out, right? Because 5 times 5 and then the 5 in the denominator would cancel out. So it ends up becoming x minus 2 plus 2 minus 2 plus 2 equals x. What about the opposite way? Let's switch the roles around here. So what we're going to do is for the x minus 2 over 5, what we're going to do is we're going to plug in the 5x plus 2 into that variable. So once you get that, that becomes what? 5x plus 2, I'm going to replace that with the variable minus 2 over 5. And whenever you replace something, make sure you put parentheses in there just to kind of help you not get confused. Because if you don't put the parentheses in there, you tend to forget about like the distributive property. You tend to kind of get things messed up. And so parentheses kind of always indicates just that you're substituting, okay, something, that you're replacing the variable. So then you go from here, it becomes 5x. You could get rid of the parentheses now and you subtract the 2, so it becomes 5x over 5 5x over 5 equals x. And since they both equal x, they are both inverses of one another. All right. I really hope this video helps. Again, let me know if you have any questions. Feel free to email me, contact me through Remind. We'll go from there. Have a good day.